So I'm briefly going to look at the rules for powers or what is commonly known as indices. If we have 3 to the power of 2, we have 3 multiplied by 3, which is equal to 9. And this is the power, this is the exponent. So you're effectively dealing with a number being multiplied by itself, and how often you multiply it by itself is determined by the value of the exponent. So if I have 3 to the power of 3, the exponent is 3, so I'm going to have 3 multiplied by 3 multiplied by 3, and that's going to equal 27. So that's what we're talking about when we're talking about powers. Let's look at some rules. So the first one I want to look at is, say if we had 3 to the power of 2 multiplied by 3 to the power of 4. Well, what we then have is, 3 to the power of 2 is 3 multiplied by 3. And then we have 3 to the power of 4, which is 3 times 3 times 3 times 3. So that bit is that bit there. And that bit is that bit there. And the answer is 3 to the power of 6. 3 times 3 times 3 times 3 times 3 times 3. Now the rule for dealing with powers that look like this, effectively what we are doing is that we are adding these two powers together. 2 add 4 is equal to 6. So if I had 3 to the power of 2 multiplied by 3 to the power of 4, we can write this as 3 to the power of 2 add 4, which is equal to 3 to the power of 6. And there's our answer. It's important to note that this number here and this number here have to be the same. If they are different, then this rule doesn't apply. So these two numbers have to be the same. So if we did another example, so if I had 5 to the power of 3 multiplied by 5 to the power of 7, well, the answer is going to be 5 to the power of 3 add 7, which is equal to 5 to the power of 10, and there's the answer. Now let's deal with division. You might have something looking like this: 2 to the power of 5 divided by 2 to the power of 3. It might be given to you looking like this: 2 to the power of 5 over 2 to the power of 3. It means the same thing. Well, 2 to the power of 5, that's 2 times 2 times 2 times 2 times 2, all over 2 times 2 times 2. Now you should be familiar with the idea of cancelling out numbers, so we can basically cancel some of those 2's out, and we're left basically with 2 times 2, which we can write as 2 to the power of 2. Now if we look at our powers, we have 5 and 3. The rule for division is we subtract the powers. So 2 to the power of 5 divided by 2 to the power of 3 is equal to 2 to the power of 5 subtract 3, which is equal to 2 to the power of 2. So if I had 8 to the power of 7 divided by 8 to the power of 2, that would be 8 to the power of 7 subtract 2, which is equal to 8 to the power of 5. If we look at the way it's written here, 2 to the power of 5 over 2 to the power of 3, it means 2 to the power of 5 divided by 2 to the power of 3. If we look at this 3 here and look at this 3 here, we've ended up with minus 3. And this leads us into another rule in relation to powers. You see, if we have 1 over 2 to the power of 3, this is actually the same as 2 to the power of minus 3. So when you've got 2 to the power of 5 over 2 to the power of 3, you could think of it as 2 to the power of 5 multiplied by 2 to the power of minus 3. Now, going back to the previous rule that we looked at, that would be 2 to the power of 5 minus 3, which is equal to 2 to the power of 2. So there's something else that you need to be aware of. Moving on to brackets. And what I mean by that is if you had 3 to the power of 2 all to the power of 4. So what that means is 3 to the power of 2 multiplied by 3 to the power of 2 multiplied by 3 to the power of 2 multiplied by 3 to the power of 2. And using what we've already, the rule that we already have used, we'd have 3 to the power of 2 add 2 add 2 add 2, which is equal to 3 to the power of 8. The relationship, if we look at what we have here, we have our 8 and we have our powers of 4 and 2. The rule for this kind of problem is where we have 3 to the power of 2 all to the power of 4, what we do is we multiply the two powers. So we end up with 2 multiplied by 4, which is equal to 3 to the power of 8. So if I had 5 to the power of 3 all to the power of 4, it would be 5 to the power of 3 multiplied by 4, which is equal to 5 to the power of 12. So that's how that works. Now, if we had 4 to the power of 2 all to the minus 3, what we have is actually 4 to the power of 2 multiplied by minus 3, which is equal to 4 to the power of minus 6. 4 to the power of minus 6, because this is a minus, we could also write this as 1 over 4 to the power of 6. And let's look at this in different ways. If I had 4 to the power of minus 2 all to the power of 3, again you end up with 4 to the power of minus 2 multiplied by 3, which is still equal to 4 to the power of minus 6, which is again equal to 1 over 4 to the power of 6. And you can play around with this as much as you want. So for example, you can think of it like 1 over 4 squared, or 4 to the power of 2 multiplied by 3, which is the same as 1 over 4 to the power of 2 multiplied by 3, which is equal to 1 over 4 to the power of 6. I want to quickly look at roots. Now, if I had the square root of 4, now actually the square root of 4 is plus or minus 2, but for the purposes here, we'll just say that square root of 4 is equal to 2. We also know that 4 is equal to 2 squared. And so that just confirms that the square root of 2 squared is equal to 2. So we can see that squaring and square rooting cancel each other out. Writing a square root as a power, so for example, if we have the square root of 4, that would be written as 4 to the power of a half. If we'd had a cube root of 4, that'd be written as 4 to the power of a third. So this 3 here is here. And if I had the fourth root, the power of 4, then this would be 4 to the power of a quarter. So that 4 there is that 4 there. Going back up to our square root of 4, or 4 to the power of a half. we know that 4 is equal to 2 squared. So looking at the square root of 2 squared, we can write this as 2 to the power of 2 over 2. So that 2 there represents that 2 there. And this is our square root. 2 over 2 is equal to 1. So that's 2 to the power of 1, which we can write as 2. So that confirms what we already know about the square root of 2 squared is equal to 2. If we looked at, say, the cube root of 2 squared, then we would write this as 2 to the power of 2 over 3. So again, there's our 2, and there's our 3. And if we had the fourth root of 2 to the power of 2, well, that would be 2 to the power of 2 over 4. Now, this 2 over 4 can cancel down to 2 to the power of a half. And I can write that as a square root of 2 if I wanted to. The final thing I want to look at is something to the power of naught. If I have 3 to the power of 2 divided by 3 to the power of 2, well, using the rules that we already know on division, this would be 3 to the power of 2 subtract 2, which is equal to 3 to the power of naught. If I had 2 to the power of 5 divided by 2 to the power of 5, I'd have 2 to the power of 5 subtract 5, which is equal to 2 to the power of naught. Let's look at the first example, 3 to the power of 2 divided by 3 to the power of 2. 3 to the power of 2 divided by 3 to the power of 2 is equal to 9 divided by 9, which is equal to 1. If I look at the second example, 2 to the power of 5 divided by 2 to the power of 5, well, this is the same as 32 divided by 32, which is equal to 1. So when you have a situation where you have a number to the power of naught, the answer is 1. We can see here that 3 to the power of naught is equal to 1, and 2 to the power of naught is equal to 1. So if I had 25 to the power of naught, this would equal to 1. 157 to the power of naught, this would equal 1. So that's why we end up with a number to the power of nothing is equal to 1. So hopefully that will give you some help in understanding some of the laws revolving around indices.